Friends, this is Mr. Nageshwar Tambake, Assistant Professor, Department of Mechanical Engineering, World Institute of Technology, Solapur. Today we'll discuss on design of spur gear, part 1, in which we are going to discuss the terminology of the spur gear and the beam strength equation of spur gear. This is what the learning outcome is. At the end of this session, learner will be able to derive Lewis beam strength equation for spur gear design. Before deriving the beam strength equations for spur gear, we'll understand what is gear terminology. So here different terminologies are given. So this we have to remember for further consideration. Here there is a addendum, dedundum. Addendum is nothing but which is the distance between this pitch circle and the addendum circle, that is called as the addendum. And what is pitch circle diameter? It is the imaginary circle drawn from the pitch point of the spur gear is nothing but the pitch circle diameter. What is pitch point? Pitch point is nothing but when the two gears are meshing with each other, then the two tooths of the two gear are meeting at a one point. That particular point is called as the pitch point. And the circle, imaginary circle which is drawn from the pitch point is nothing but a pitch circle diameter. So here another next important parameter is face width. Face width is nothing but it is the thickness of the tooth measured along the axis of the tooth. And the next thing is that the face and flank of the tooth. Face is nothing but it is the upper portion of the tooth measured. It is the upper portion of the tooth which is mating with the another tooth. Flank, which is below the portion of the face. So now here the thickness of this particular whatever the circular pitch, the next parameter is circular pitch, in which it is the distance between a point on one tooth and the point on the successive tooth of the same gear is nothing but a circular pitch. And this particular whatever the distance is there, that is tooth space. It is the distance between the two tooth, that is nothing but a tooth space. So these are what the important dimensions of this particular gear. So further dimensions are also there that you can see over here. So whatever I discussed, those are the important parameters that we are considering for calculating the gear dimensions. Now module of the gear. So this is what the different types of module. As module increases, the size of the tooth increases. Now here we can see the table recommended series of the module. So this is what the table in which for the pinion and the gear the modules are recommended. Now forces on the gear tooth. Here on the left side the pressure angle is shown. So what is pressure angle? So pressure angle is nothing but the line drawn from the pitch point, which is line drawn from the pitch point and to the common tangent, that whatever the angle between it is there, that is nothing but a pressure angle. So what is this particular pitch line? So this particular pitch line is drawn tangent to that particular pitch circle diameter, and this is nothing but a common tangent. So what is pressure angle in another way? So it is the angle between the common normal of the pitch circle diameter and to the common tangent of the pitch circle diameter. So that is nothing but the pressure angle, alpha. Now we can see the different forces acting on the gear tooth. So here we can see, my dear friends, So Pt is nothing but the tangential force, Pr is nothing but a radial force, and Pn is nothing but resultant force, normal force that is acting on the gear tooth, and alpha is nothing but the pressure angle. Now we'll see the relation between Pt, Pr and Pn. So these are the component of the forces. Now tangential force, how to calculate the tangential force? So Pt is equal to 2 mt upon d dash. So here mt is nothing but the torque which is acting on the gear, and d is nothing but pitch circle diameter. So with the help of which we can calculate the tangential force. So mt can be calculated with the help of power. So now radial force. So what is the relation of radial force with the normal force? So Pr is equal to Pt tan alpha. So this is the relation between Pr and Pt. So once we know the tangential force, so we can able to calculate the radial force. Now before going to derive the beam strength equation for the spur gear, we will see analysis of a cantilever beam. So this is the fundamental thing. Once we know this, how to calculate the beam strength of this particular cantilever beam, then we can able to calculate the beam strength equation for the spur gear. So this is the beam which is having distance, which is having the length. This is what the tangential force is acting. Now that tangential force is Pt over here. This is the L. So what is the moment? So moment is equal to Pt into L. So this is what the section of this particular cantilever, the rectangular section is there. So this rectangle is having the breadth B and the thickness T. So maximum bending stress at support is what? The sigma B is mby divided by I. So this is the fundamental equation that we know. Now, so before going to derive the beam strength equation, we have to recall the bending of cantilever beam, and these are what? The bending moment for the cantilever beam and the section modulus of the beam that we must know. So bending moment for the cantilever beam, that we can see that knowing the permissible bending stress, sigma B is equal to mby upon I, and it is possible to calculate area of cross section. Now gear tooth as a cantilever beam. So this is what the gear tooth, and which appears to be a cantilever beam. Here we can see that this particular whatever the B is there, that is the face width, T is nothing but the thickness of the tooth, and Pt is nothing but a tangential force. H is the height of the tooth, with the help of which we can able to derive the beam strength equation of the spur gear. So here this is what the front view of that particular tooth. Here Pt and Pr are the tangential and radial force respectively, and this is what x-axis is the section, and this is what the T is the thickness of the tooth, B is the breadth here over here. So with the help of which we know the tangential force that we can calculate with the help of Pt is equal to 2 mt upon d, and radial force that we know Pr is equal to Pt tan alpha. Now some assumptions that we have made for deriving the beam strength equation of the spur gear. So effect of radial force Pr is neglected because for the sake of simplicity. Tangential component Pt is uniformly distributed over the face width. The effect of stress concentration is also neglected. At a time, only one pair of tooth is in contact. That assumptions that we have made over here. So with this assumption, we will derive the equation for beam strength. So at the weakest section XX, if we see what will be the beam strength. So and if we take the moment, mb is equal to Pt into h, and I is equal to, we know this is 1 upon 12 Bt cube, and y is equal to T upon 2 that we are taking over here. So bending stress, what is bending stress? Sigma b is equal to mby upon I, that already we have seen. Put all the values in this equation, we will get this. So simplifying the equation, we are getting Pt is equal to B sigma b T square upon 6h. Now will multiply and divide by m module. So this is what the equation that we are getting. T square by 6hm is nothing but a Lewis form factor that we are considering as y. Y is equal to T square upon 6hm. So this is what the Lewis form factor, and whatever the and tangential force Pt is equal to mb sigma by. Now tangential force become Pt is equal to mb sigma by, and Pt is nothing but a tangential force as well as the bending strength of the spur gear. So this is what the maximum value of tangential force. This is also called as Lewis beam strength equation. So Sb is nothing but beam strength of the gear tooth, sigma b is nothing but permissible bending strength. So this is what the reference is. Thank you.